Hey everyone, it's Miss Cronky again, here to talk to you about exponents and logarithms. So I want to start off with a review of exponents, which follows along pretty nicely from our previous notes having to do with the exponential function and exponential models, because we were talking about, what's really important for an exponential function is that your variable is in your exponent. So when I did those graphs in the last video, we saw where I was plugging in different numbers for the variable exponent and then evaluating. So just to kind of remind yourself what are exponents and how some of the special rules of exponents work. So obviously if we have something like 2 cubed, okay, we're all aware that that means 2 multiplied by itself 3 times. So 2 times 2 times 2 is 8. So exponents are really just a way that we can recognize repeated multiplication. And we talked about this in our last chapter right before spring break when we were talking about geometric sequences. Remember, they had common ratios, and that was when we were like multiplying by the same thing every time. So we saw that as an exponent. I had mentioned in the last video about negative exponents. So if we had 2 to the negative 3, just want to clarify that there's an old rule you learned back in Algebra 1 where a negative exponent will reciprocate or flip what it touches. So the exponent negative 3 is touching the 2. So it's going to flip that 2. Instead of being 2 over 1, it'll be 1 over 2. And now the 2 will be raised to a positive 3. So then this will come out to be 1 over 8. If you had something like 1/5 to the negative 2, then the negative exponent is touching the 1/5. It's going to flip that to be 5 over 1, and then it would be 5 squared, which is 25. So always remember that the negative exponent will flip the base, the thing that it's touching. It doesn't flip the exponent, it flips the base. And then negative exponents never make things negative. Like this 1/8 is still positive, this 25 is still positive. So we can't really raise a positive base to any exponent and get a negative answer. And then, other things that you might know about exponents, obviously if I took 3 to the first power, that's just 3. If I took 4 to the 0, anything raised to 0 is equal to 1. You might remember that from Algebra 1. That's the zero exponent property. And then we talked about in first semester, we had some fraction exponents. So let's see if you remember this. I'll do 25 to the 1/2. And if you have a fraction exponent, I always said last semester in chapter 5, that your root is in the denominator of your fraction. So this really comes out to be the square root of 25, and then you could say like raised to the first, but you don't have to write that down, so that would be 5. We also did some more complicated fractions in chapter 5 where like we did like 4 to the 3/2. So then we knew that the root was in the denominator, that's the square root of 4, and then it's still being cubed. So we can say that's 2 cubed, which is 8. Okay, so it's kind of like there's a lot of little rules about exponents to remember. The negative exponent flips what it touches. So sometimes makes it into a fraction. A fraction exponent is a root. Okay, 0 exponents make things equal to 1. So it's important that you understand some of those basics of exponents so that you can do logarithms. So this is a brand new idea for us, the idea of a logarithm. And what I want to impress upon you, like one big takeaway for you in this video and what you would want to carry into your class next year is a logarithm is just a fancy notation that mathematicians made so that we don't have to write out the question, what is the exponent that makes this true? That's too many words, it's too much to write. What is the exponent that works? Okay, so a log is a fancy way to ask a question about an exponent. So for example, if I had this statement, 5 to the x equals 25, I would guess that most of us could think about it for a quick second or two and come up with the answer that x equals 2. Okay, because, so this is a BC, because 5 squared is equal to 25. Okay. Now, sometimes you won't know exactly what the exponent is. So, maybe it will be something like 4 to what exponent is 1024. And I don't really know 4 to a lot of exponents by heart. Actually, I do, but maybe you don't. And so maybe you'd get out a calculator and you would just like kind of guess and check for a while. 4 squared is 16, 4 cubed is 64. If you do 4 to the 4th, you'll get 256. And 4 to the 5th is 1024. So this is because 4 to the 5th equals 1024. Okay. But mathematicians created a way to write these questions, 5 to the x equals 25 and 4 to the x equals 1024, and we call it a logarithm. So we can write that question as a log base 5 of 25 is equal to x. So it's saying what exponent, and exp apostrophe t is my abbreviation for exponent, of base 5, or I'm going to say 4 base 5, gives us 25. So 25 is the answer, and the base is this, I say subscripted, meaning it's below the regular line of text, so it's kind of like underneath the line of text. So the subscripted number is the base. Or for 4 to the x equals 1024, we can say log base 4 of 1024 equals x. And this is saying what exponent for base 4 gives us 1024. And right now we're like, why wouldn't we just ask the question, or why wouldn't we just leave it in the highlighted forms? It seems a lot easier. Well, of course, you might run across problems, especially like in the modeling examples where you're trying to solve for a time, and it's not going to come out to a nice number like x equals 2 or x equals 5. It's going to be a decimal. So we had tables for logarithms, or you have a calculator that can do logarithms and can give you more exact values in decimal form, okay, and then just simple guess and check, and it comes out to be more efficient. So I'm going to give us a definition for a logarithm using some variables now that we've seen it with some numbers at play. Remember, it's just a fancy thing that mathematicians made up so that they don't have to write all these words over here. What exponent for this base gives us this answer? We can just write it out in a little mathematical sentence. Okay. DEF apostrophe N is my abbreviation for definition because I'm too lazy to write it out. So definition of a logarithm. B to the x equals y. This is what we would call exponential form. And then I'm going to use an abbreviation from geometry, IFF, if and only if. So that means that this is a biconditional statement. It goes both ways, forwards and backwards. B to the x equals y if and only if log base b of y is equal to x. And this is that same statement in log form. Okay. And again, one of the big takeaways that I want for you guys to leave with when you leave this video, when you go into your class next year and you start hearing your teacher talk about exponents and logs again, I want to impress upon you this idea that the answer to the log, this x over here on the right side, the answer to a log is, and it's x, look at where x is in the other equation, it's an exponent. So the answer to a logarithm is an exponent, meaning you're trying to think about these questions that I have phrased up here. What exponent for that base gives us this answer? So really try to understand the notation, and that makes answering all the questions about logs seem a little bit easier, or at least makes sense. So it's not like some foreign language. So the answer to the log is a logarithm. Okay, you're gonna do some practice with exponents and logs, and one of the sets of practice is gonna be changing forms. Okay, so I'm just gonna say changing forms here. Read the directions, it'll tell you exactly which form to change from, but I'm gonna jot down some things that we know to be true. So 2 squared is equal to 4. That's probably not my best one because I have two of the same numbers, so let me change it. Let's do 2 to the 4th equals 16. How about that? Okay, so this is an exponential form. It looks like b to the x equals y. I'm going to change it into the log form. Log base b of y equals x. And in order to do that, I'm going to have to insert the log, the log, okay, short for logarithm. And I put the base in the subscripted position, okay, where this little b is. So I'm looking at my exponential form, and I'm trying to decide what is the base to the exponent. So I can identify the exponent is that 4. The base is whatever the exponent is touching. So my base is 2. So I'm going to have log base 2 of essentially the answer to your exponential. So whatever y is the thing that your exponential statement equals. So we're going to say log base 2 of 16 equals, and remember, the answer to a logarithm should always be your exponent. So we say it equals 4. I'll do another one. Let's do, excuse me, 6 cubed equals 216. Turn it into log. Log base 6, because that's the base to the exponent, of what number? So this is like the number that you would get when you do your exponential work, 216, and then the answer to the logarithm, remember, is always your exponent, so equals 3. Let's see, I could do let's see, 100 to the 1/2 equals 10. So that's really saying, just a side note, that the square root of 100 equals 10, and I'm sure that you agree with that. That's true. So we could turn this into a logarithmic expression. We could say log base 100 of, what's the answer? 10, and then it equals 1/2. So you can have a fraction in there. Okay. Let's see, I'll do one with a negative exponent. So we agree that 5 to the negative 2 is equal to 1 over 25, because that would be 1 over 5 squared. And then that's going to turn into the log base 5 of 1 over 25, and it equals the exponent, which is negative 2. And then we can change forms. We can go the other way as well. Let's say I give you the log base 2 of 64 equals 6. Okay, so I'm giving you a logarithmic form, and I want you to turn it into an exponential form. Well, when you're looking at your log form, you want to search for, like in an exponent, you want to know what the base to your exponent is. So your base, always start with that subscripted number right there. Your base is 2. Okay. Remember that the answer to the log, the thing that the log is equal to, that's always your exponent. So this would be 2 to the 6th, and then it equals that thing that you're taking the log of. So 2 to the 6th equals 64. I could do the log base 3 of 1/27 equals negative 3. Okay. So rewrite that in exponential form. My base is 3. My exponent is what the log is equal to, so 3 to the negative 3. and then it equals 1 over 27. Stop and think, does that actually make sense? Because when you rewrite these should always make sense. Okay, so I'm just going to do a little because over here. 3 to the negative 3 is equal to 1 over 3 cubed, which is equal to 1 over 27. So yeah, it does check out. Okay, so I'm gonna stop right here with the rewriting, and I'm gonna take a quick minute to tell you about something called the common log. Okay, common log is a special log where I have that highlighted 2 above, or like the 3 right here, where normally I have to tell you what the base is because the base can change. But the common log is a base that's so common, I don't even have to write it. It's kind of like back when we did the roots. In like the square root, we know there's really like an index of 2 out front, but we don't have to write the little 2 when we want to do a square root. We just have to write the little 3 when we're doing a cube root, or a 4 if we're doing a fourth root, so on and so on. So the common log, what you need to know is base 10, okay? And this should make sense to you that this would be a really common log, because you think to like scientific notation, when you raise 10 to certain, it's like a number times 10 to the 5th to show a really big number, or 10 to, or times 10 to the negative 5th to show a really small number. So this is a very common log, and I can write something like this, log 100. Okay. Now, some people might be like, well, what is the base? You forgot to write a base, because where there should be a subscripted b, there's nothing. Okay. So I'm going to make a little note to myself. Base 10. Don't have to write it. So if you ever see one, and you might see it on your homework, where it looks like it's missing the base, it's not missing the base. It's the common log. So it will be base 10. And I'll finish this one out. And it is equal to 2. Okay, so we would say log 100 equals 2. And that's because 10 squared equals 100. If you brought your calculator home, or you want to check an online calculator or your cell phone calculator, there is a log button. And most of the calculators don't have a place for the base, but some of them do. So most of your calculators will just have one log button that says LOG. Okay. And that log button is specifically for base 10. So you can't do any of these examples that I was doing up here that have any of the bases that aren't 10 in your calculator, unless you know something called the change of base formula, okay, or your calculator changes base for you. Okay, so now I'm gonna do some examples where I evaluate a log. And I want you to really focus on without a calculator. I talked about there is something called a change of base formula. Some of the calculators might do it. But we really want you guys, before you go to pre-calc or algebra 3, to feel comfortable with what is a log. Okay, so these are problems you want to be able to do without a calculator. So I'm going to give you log base 4 of 16. Okay. Now remember, don't get overwhelmed by the notation of this. This is a fancy way for us to say, what exponent do I need for base 4 to get 16? So you're thinking about that in your head. Okay, what exponent do I need for base 4 to get 16? Hopefully you're thinking about that and you're saying that should equal 2. Okay, so the answer to log base 4 of 16 is 2. Now, it might be really helpful for you here, like on your homework, is to write down why. Because 4 squared is 16. Yes, that makes sense. Okay, let's evaluate another one without a calculator. Let's do log base, how about 64 of 8. Okay, log base 64 of 8. So I'm thinking about, and I'm going to show you, like, maybe I don't think about that whole like wordy sentence, you know me. I'm thinking about, what does this notation log base 64 of 8 mean? Okay, what did the mathematicians mean when they wrote this? The base is 64. So there's some exponent. I'll put an X up there. I don't know what it is. And it's got to be equal to 8. Okay, so 64 to what exponent equals 8? Well, I'm going from 64, a big number, to a smaller number. So what kind of exponent would do that? It's not turning it into a fraction, so it's not a negative exponent, but it's probably a fraction exponent. You're going from a big number, 64, to a smaller number, 8. What root are you taking of 64? A square root. So then the exponent that you're looking for is 1/2. And again, if it would help you out, write it out, because 64 to the 1/2 is equal to 8. That means the square root of 64 equals 8. Okay, makes sense. Let's see. I'm going to try to think of another one. Let's do log base 8 of 1/2. Okay, we're evaluating this one without a calculator. So these are going to get tough, but you really want to focus in on like what's happening with exponents, because logs are really just asking questions about exponents, right? 8 to what exponent equals 1/2? Okay. Well, I'm going from a base 8, which would be like 8 over 1, and it's turning into a fraction, 1 over 2. So what kind of exponents turn things, like flip them or reciprocate them? Negative exponents. So I probably got a negative exponent at play. Okay. And then how could I go from 8 to 2? So I'm going from a bigger number, base 8, to a smaller number, 2. Kind of exponents will do that? Probably another fraction exponent, because I'm going to be taking the root of something. So what root of 8 is equal to 2? That's the cube root. So a cube root is an exponent of 1/3. So the negative is going to turn it into the fraction 1/2. The 1/3 is going to cube root the 8. Okay, so the answer there would be negative 1/3. And let me write out my because statement over here. 8 to the negative 1/3 is really 1 over 8 to the positive 1/3, which is 1 over the cube root of 8, which of course is 1 over 2. So you might have skipped some of those steps. Maybe you won't write all of them down, but I just want to be clear about like what's actually happening as I transform that exponent. Okay. Okay, last thing, just really quickly, because you'll have some problems like this on the homework, so I want to show them to you really quickly, is a problem where I might ask you to solve an equation. Okay, and really you're kind of using the things that I've done above, either rewriting, so changing forms, or just thinking about like evaluating the log like I was doing here, like trying to answer the question of what the exponent is. So let's say I do log base 3 of 243. Oops. I'm going to give away my answer here. I'm going to change my equation. Log base 3 of x equals 5. Okay. You might guess what the answer is. Okay. But here's the thing about solving this equation. You want to solve for x, but x is not alone. It has a log base 3 in front of it. And we're going to get more into this later on in the chapter, but it's good for us to see right now, you know, what can I do with this log equation? I could start right here at the base 3. I know that the thing on the other side of the log is my exponent, 5. That's equal to x. So then I could type that into my calculator. and x is 243. That's amazing. Okay. Another example that I could do would be 4 to the x equals 2. Okay. And I really feel like on this one, because I'm not doing any calculator work, you could probably just think about it like this. But one thing that you'll want to be familiar with going forward is if you have an unknown or a variable up in the exponent, then you can rewrite it as a log so that you can solve it with a calculator. So this would be log, think about what's your base 4 of the answer to the whole problem, which is 2, and then that's equal to x. Now, if we knew the change of base formula, or if you have a calculator that does change the base, then this would be very simple. You just type it in. Of course, what I was doing up above for the evaluating the log with the calculator is essentially thinking about what the problem was originally, 4 to the x equals 2. And what kind of exponent will do that? Go from 4 to 2. It's making it smaller. So again, not a negative, because that would turn it into a fraction. It would flip it. But a fraction exponent will take a root. What root of 4 is 2? That would be the square root. So x must be 1/2. Okay, so 4 to the 1/2 is equal to 2. If you want to type 4 to the 1/2 in the calculator, use your exponent button, but remember that you would have to put in a 0.5, or you'd need to put parentheses around the 1/2 in order for it to equal 2. Okay. So you've got an assignment with changing from exponential to logarithmic form, vice versa, doing some practice with evaluating the logs. Think about this question: what exponent do I need? Okay, to get these numbers, and then there will be some problems similar to this where you're solving for x. All right, good luck, have fun, and I will see you guys again soon.